Alright, hello everyone. So let's solve another trigonometric substitution problem. So far we saw examples where we had the substitution as secant and sine. Let's look at a case where our substitution is tangent here. So of course, if you look at the format of the square root, the substitute from the table has to do something with the tangents. The question is, what is a? So a square is 9. So square root of 9 is 3. So a is 3. Okay, now take the derivative of x. Remember, you have to also replace dx also, right? Substitution involves two steps. So derivative of tangent theta. What is the derivative of tangent theta? It's secant square theta. If you don't know this, note it down. You may need it in future. So dx is 3 secant square theta d theta. Okay. Alright, so this is something that you have to know. You have to memorize. Perfect. Now let's do the substitution. So x square is 3 tangent theta square plus 9 dx is 3 secant square theta d theta. Alright, so 3 tangent square theta is 9 tangent square theta plus 9 times 3 secant square theta d theta. Don't drop that term, okay? Alright, so here we can factor 9 inside the square root. So we get tangent square theta plus 1, 3 secant square theta d theta. So now tangent square theta plus 1 is actually secant square theta from the Pythagorean identity. So it's 9 secant square theta, here 3 secant square theta d theta. So what I'm talking about is 1 plus tangent square theta is secant square theta. That's the Pythagorean identity, okay? Alright, so now we can take the square root. No subtractions or additions inside the square root. So we can take the square root. So 3 secant theta, right? If you take the square root of 9 secant square theta times 3 secant square theta d theta. 3 times 3, 9. So we can take 9 out. So we have to integrate secant cube theta d theta. Now how are you going to integrate this? So that's a tricky one. I think I explained how to integrate secant cube theta in the trigonometric integration video series. Okay, so this is a little bit tough integral to solve. Now let's focus on what happens after we integrate. So I'm gonna give you the answer. So integral of 9 secant cube theta d theta is actually, well, let's see, secant square theta sine theta over 2 plus half natural log tangent theta plus secant theta. I know in most of the colleges, if you in the exam, if you come up with a problem where you have to integrate secant cube theta, I'm sure most of the time they will provide this answer in your formula sheet or something in your instruction sheet. Okay, so we forget 9, so we have to have 9 here. Okay, so this is the integral after we integrate secant cube theta. 9 times secant cube theta, this is what we get. Okay, let's say this is given to you. I'm sure it will be given to you in most of the colleges. Okay, all right, so now what I want to focus is, well, the final step. How are we going to replace theta back into x? Well, we use the substitute. So the substitute is x is equal to 3 tangent theta. So tangent theta is x over 3. Okay, so now every term in the solution contains at least tangent, secant, sine. So we can't just take inverse and right. We have to do that triangle trick. So let's do that. So tangent theta is x over 3. So let's make a right angle triangle. Theta is, well, tangent is opposite over adjacent. So this is x, this is 3, opposite over adjacent. So the hypotenuse is, using the Pythagorean theorem, x square plus 3 square square root, right? If the hypotenuse is c. Alright, so c is actually x square plus 9 square root. Now we know our little secret. The missing side of the right angle triangle most of the time is equal to the square root part in the integral. Is it the case here? Yes, of course. Okay, all right, so now let's rewrite the final solution. Now secant square theta. So from the triangle, how do we find secant square theta? Well, secant is, think about this, secant theta is 1 over cosine square theta. So secant 1 over cosine theta, I'm sorry. Secant square theta is then 1 over cosine square theta, right? Just square it. So what is cosine theta? Well, cosine theta here is, well, let's write down. Cosine theta from the triangle is 3, that's the adjacent side, over square root x square plus 9. So cosine square is 3 square and square of this. So 3 square is 9, square of square root, then the square root is gone, so 9 over x square plus 9, right? But now you need 1 over cosine square to get secant square, right? Okay, so then secant square is going to be reciprocal of this, right? X square plus 9 over 9, right? Because 1 over cosine square is secant square, cosine square is this, so we take the reciprocal. So secant square theta is x square plus 9 over 9. Okay, now you need to find sine theta, right? So what is sine theta? Opposite over hypotenuse, so it's x over square root x square plus 9 times 2, because 2 here in the problem, plus, oh I am running out of space, let's make space, perfect, okay, plus half natural log. What is tangent theta? Well, tangent is opposite over adjacent, so it's x over 3 here, plus secant theta. We found secant, oh okay, secant theta is 1 over cosine theta. So what is cosine theta? Let's write it again. Cosine theta is 3 over square root x square plus 9. So secant theta is reciprocal of this, so square root x square plus 9 over 3. Oh wow, okay, so this is the final solution. So most important part of this problem is that conversion. How do we do the conversion for a complicated problem? I think this is the most complicated conversion that you can get, okay, because it involves a lot of terms. But try to pause the video and try to do the problem by yourself. Now you have the answer, try to convince yourself. That's the best way to learn. Try to do the problem again by yourself without looking at the video, then compare. Okay, that's the best way to learn mathematics. Okay, all right, so I'm gonna solve more trigonometric substitution problems, and hopefully you will watch those other videos to learn more. Bye bye, thank you.